Hello Foxfire family, welcome or welcome back. I'm glad you're here because today is a very special video. We may not be making a knife, but it's something cool that I'm excited to show you guys. But before we get into what it is, let me introduce you to Freya, the heart and, let's be honest, the brains of Foxfire Industries. She's about 10 years old, and she's been with me and my wife through our highs, lows, and everything in between. She's a wonderful companion, and she usually manages to keep me on track. But unfortunately, 2 months ago, she was diagnosed with bone cancer, and our only option was to amputate her right foreleg, which was heartbreaking. But our girl's a trooper, and she gets around pretty well on three legs. However, I think we can do better. So come with me on a journey to take our tripod princess and get her back on four paws down. Let's get to work. As soon as we knew we had to amputate, my brain started putting together pieces. I wanted to make something that emulated the way her natural appendage moved and weighed approximately the same. I wanted to come as close as possible to feel like she never lost anything at all. Now, was this ambitious? Absolutely. Did I flunk out of art school? Didn't even apply. But if you can sift through my chicken scratch, you'll see we have some copper plate attached to brass rods, cast aluminum joints, and more brass, with springs to simulate her muscles and tendons and give her a sense of motion while she walks. Spoilers for the video to come, I didn't quite achieve my goal, but we got pretty close, and we're going to keep working on it. And I hope as you watch you'll come up with some ideas and let me know how you think I can improve. So, we're going to start building from the top of the dog down. I started with some 6x6 copper squares and some copper rivets. Now, I had peened handle pins before, but I'd never done rivets, so this was an interesting learning experience. They riveted up a lot tighter than I expected, and once they were together, they provided more rigidity than I thought they would. And that's even with the slop job that you're watching happen on your screen right now. But, all things considered, 5 little rivets later, and we had the base for our build. After that, we draw aggro from every armorer on this platform, while I don't heat my copper, and hammer it into the makeshift armorer's bowl that I made a few weeks earlier. It worked pretty well, but I'm open to any criticism. Seriously. Any of you guys who make armor on here, please tell me how to do this better, because there will be a Mark II in the future. But learning curve aside, we soon had our breastplate, and it was time to test it. Hey Freya, let me see your chest real quick. Next, I had to figure out where to get the aluminum for the joints. And since petty scrap theft wasn't on the table, I elected to cut up some aluminum wire and melt it down in a crucible. Was this productive? Yes. Was it an absolutely mind-numbing task? God, yes. The things we do for our pets. But one snip at a time, we took most of this fool and filled this crucible that definitely was adequate and I didn't have to replace later, and melted it down.
3 hours later.
Bad SpongeBob references aside, it did take me close to 3 hours to fill up this crucible, but all well worth it. And if you look closely in this clip, you can see me realize that this is not nearly the amount of aluminum I need. But we'll get to that in a minute. Because now that we have our aluminum, we need to make our joint blocks. And this is what I had in mind. I found a good design from Virtuous 70 on Thingiverse. This was actually made for an action figure, but it'll suit really well for our purposes. We just have to take it over to the old slicer program and scale it up just a tad. Maybe 400%? Nope, way too big. 300. Still huge. 250? Just right. And with our design expertly adjusted, we can take it over to my Kyber Pass AK level jank of 3D printer. And you can thank Brandon Herrera for that reference. And we get printing. Amazingly enough, Not only did my printer complete the build, it didn't even catch on fire not once. I was impressed. And with my fire suppressions woefully underused, we have our first template for how Freya's joints are going to work. They're a little ugly, a little broken, hard to look at, but functional. Just like me. And once I was done self-deprecating, I put them together to see how they fit. Amazingly pretty well. With a little bit of trimming down and filling in some gaps, we got pretty close to the final form of how the joint was going to work as the elbow, which I don't remember if I mentioned or not. This is the elbow. Neat, huh? Now that we have our form, it's time for me to pound sand. No, really, I'm going to pound sand. The idea here is to go for something kind of like lost wax casting, but instead of using wax, we're going to be using whatever the hell printer filament is made out of. But hopefully it'll work the same. Let's find out. I started by packing the joint channel as tightly as I could with the molding sand, and this worked pretty okay. There was some cleanup required, but overall I would keep this method. And then we just pack the rest of it in as tightly as we can. Now, if my bad jokes have ever made you want to tell me to go pound sand, too late. I already did. And with that, let's get this in the fire. As I mentioned earlier, my previous crucible just didn't have the volume I needed, so we upgraded to a proper kiln and a better sized crucible. Let's get it hot and get it poured. This is actually my first aluminum pour, so, I didn't die. That's pretty good. I did, however, get a lot of vapor release from burning plastic, and also I think this wire was coated with something, I'm not exactly sure what, so if you're going to attempt this method, I highly recommend getting a respirator. And speaking of the coating, this method generated a ton of slag. Fortunately, it was very sticky, it all floated to the top, and it was easy to scrape away. And honestly, the quality of aluminum we got out of this was a lot higher than I thought. You know, as soon as I could get it out of the mold. Mushroom. And here we come to what's going to be a recurring theme, unfortunately. I lost a ton of footage. This was a long project spread out over several weeks. I work a regular job, so this was a weekend-only thing. But we got the parts cleaned up, they look pretty good, and they are unbelievably strong. Which is a good thing, because now it's time to butcher these things on the drill press. The plan is to use brass anchors, inserts, into the blocks. That way we can thread and screw in the brass rods that'll give us some more strength without tearing through the aluminum. Or at least, that's the plan. And with our insert holes perfectly aligned and definitely exactly where I wanted them, let's see if we can't get those mounted. I thought the threads on these would slip through the aluminum pretty easily given the hardness difference, but, well, you'll just see for yourself. So yeah, the lip broke off. Build over. I guess this is it. I surrender. But then I remembered I'm not French. So what we're gonna do is grind off the threads, and then we'll percussively fit the inserts into the blocks. Now this might seem a tad bit unscientific, but I got a surprisingly solid fit up. So we're gonna go ahead and build the rest of the joint out the same way. I did have to switch to the hand drill just because of the shape of this part. It didn't really play nicely with my drill press. Potato tomato. Now on the lower part of the support joint, I did have less surface area to work with, so we went from 4 to 3 support rods. And additionally, because I was so close to the edge and didn't get quite as tight a fit on the bottom one, I had to take a peener and smoosh in the holes. But again, this led to a very tight fit up, and I'm happy with it. Now, to make sure the joint didn't fail under Freya's weight, I wanted to use something sturdy for the pivot pin, something like stainless steel. But stainless steel is significantly harder than aluminum. So, to keep it from tearing through this expertly crafted joint block that definitely doesn't suck, I'm going to use an intermediate material. We're going to go with brass again this time, and I'll show you what I mean by that. For the upper portion, we're just going to pressure fit brass collars. This will allow the pin to pivot easily inside of them, without requiring too much lube and shouldn't have too much wear and tear. And for the lower portion where we have less material to rely on, we're going to upset the same piece of brass, making sure it tightly fits inside of the hole drilled in the aluminum. This will basically give us a reinforced joint, and once we grind it flat, you almost can't tell the difference. So smooth. Now, I am no machinist, so the original fit up wasn't quite what I had in mind. Really limited the range of motion, and I wasn't too comfortable with the contact points not rubbing themselves to pieces. So, back to the grinder, a little reshape, a little trim, a nip, a tuck, and we're almost there. See? Much better. This is the range of motion I had in mind. Will this come back to bite me later? Absolutely. But for now, we just crimp our brass closed, and that should hold our pen in place and allow it to rotate freely. Now, to figure out how to get our brass rods to attach to our aluminum blocks. These are threaded inserts, so we're just going to take the depth here, and then the fun starts, because we need to thread down these brass rods. Now, this was more difficult than I thought, mainly because I don't have an apparatus, but yeah, that's some quality sound. I'm not going to torture you guys with the whole process of this. But once the threading's complete, they thread in nicely. Now you'll notice these go straight up, so the next step is to make these distinctly dog-shaped. And with the Robo Shoulder Dogified, all we need to do is cut down to the appropriate length, and once we do, here's where the fun begins. As I'm sure you saw in the previous clip, brass heats and bends pretty easily at low temps. However, what it doesn't do particularly well is forge. You have a very narrow temperature window. But what we need to do is forge our brass rods into something flat that we can then rivet to the plate. So here's what we're going to attempt to do. Heat them with a torch again, and keep them in just the right temperature range. Forge flat without cracking to pieces. Now, I did not nail this, but we'll get to that in a second. In the meantime, while I'm tweaking these bars to get them just perfect for Freya's shoulder, let me talk about her treatment. The type of bone cancer she had was an osteosarcoma. which amputation treated perfectly, but unfortunately, it likes to jump to the lungs. So Freya is currently undergoing chemo, and as you can imagine, the surgery and the chemo together are quite expensive. So if you would like to support Freya's treatment and help us get her through this, you can like this channel, subscribe, and also subscribe to my wife's channel, Val Foxfire Studio, where she's currently running a series of oil paintings to support Freya's treatment that will be available for sale. You can find those videos in the link description down below, and I really hope you enjoy them. My wife is way more talented than I am. But as we draw these tweaks, twists, and bends to a close, let's get back to the video. As you can see, we've got it married up just about right, and I'm ready to start riveting these together. Beep. Now, with these marked, approximately, I cut some additional brass, and we're just going to use those to flatten out and connect the shoulder piece to the plate. And here is where the pride before the fall comes in. This to me looked great, and I was very optimistic. So, we once again heat our brass and start the hammering. But you remember what I said about brass liking to crack if it's not hot enough to forge? Well, here's where we came into it. Now, I figured out the heat about after my first attempt, and I noticed some surface cracking on the first piece that I forged down, but I wasn't too worried about it. So we just plugged along. And here you can see me heating the backside of the rivets, thinking everything's going swimmingly. But it did not. And with one last heat and one great huff, this is where we ran into problems. You see, those micro cracks were a little more than micro cracks. And I gotta be honest, the only reason this worked out at all was I got extremely lucky. Because with just a few hammer taps, there it goes. That whole piece just broke away. But we were able to recover. You see, we have good rivets there, and not so good here. But let's get it fixed. Now, with the shoulder complete, it's time to move on to the foot and forelimb, and we're going to start with the feet. God, I hope that doesn't draw the wrong kind of people to my channel. But, second verse, same as the first, we're going to fill this whole crucible with aluminum fencing wire. This took forever. Now, again, I lost a ton of footage, but what we're using for the foot is basically the same portion of the elbow joint, the bottom smaller portion. And I found a 3D print of a robot dog foot. You know, the creepy drone dogs that I think everyone hates at this point. But anyways, I swiped that design and printed the very bottommost foot portion. And we're going to do the same thing. Use basically a lost wax casting method to burn out and make an aluminum foot piece. I am trying a sprue mold this time, which is my very first attempt, and it turned out okay. But with more sand pounded and packed, it's time to start pouring. This little crucible mold thing that I got off of Amazon is hugely helpful and much better than I think the gardening pot I used for the first round. And once again, when you're burning these plastic print parts, it does produce a lot of vapor. And anytime you're casting unknown metals in general, please wear a respirator. Zinc poisoning hits you before you know it, and passing out on top of a crucible liquid metal, not a good look. But, speaking of not looking great, here are the cast pieces for our feet. Got a little robot dog foot here. Came out looking a little rough, but we can clean it up. And clean them up we did. You can see it here. I lost the footage. But what we're going to do now is just use a die grinder and cut in the channel the joint's going to fit in. We're doing the same brass reinforcement to keep the steel pin from eating through the aluminum, although honestly, whatever they make that steel fencing wire out of is pretty tough. And it looks pretty good. So, now we're hammering in the brass inserts for the foot. This is going to cause us some problems later, but we'll get to that in a moment. And just quickly crimp down our ankle joints and the foots together. Now, looking here, this is kind of roughly what I have in mind. Now, what I was talking about earlier is when we try to screw brass rods into these inserts, they can't spin two directions at once. Now, that's not a problem for one, but when you're trying to screw three in together, you can no longer rotate the foot. And that'll be a problem that we'll solve a little interestingly. And just a proof of concept here, it does hold together with one rod screwed in. I just didn't really trust it to hold her weight. But before we get to anything else, let's do some creature comforts. We're going to add straps to hold it onto Freya's body. One going across the chest from here to here, and then one going across the back. And, yeah, don't worry about that. So just quickly marking, we're going to go with rivets again. However, I learned my lesson on the frame. We're just going to use pre-made push rivets. So a quick drill through the copper. And because these straps are nylon, I used a wood burner to pre-burn the holes. That way we don't have runners. And here we're using definitely the right tool and just crimping our rivets shut. With 6 of these per strap, they're plenty strong. And the buckles are pre-made. I mean, I wouldn't climb with them, but they'll definitely hold a leg on a dog, which is a wild statement to say today. Now, for the ultimate comfort, I got hold of a memory foam mattress, or what was left of what we used to make Freya's dog beds, and we lined the hole inside of the plate, being sure to cover the edges. And I just used 2-part epoxy to secure it on there. And there we are. I went with a wool wrapping around the epoxy. 1, because I think the green looks pretty nice with the copper. 2, because it should be comfortable and slightly antimicrobial. Now, joining these rods together. The ones I got from Amazon, way too big. Not what I ordered. However, where Amazon failed, my hometown hardware store succeeded. Suck it, Jeff Bezos. We're going into selfie mode, and forgive the shaky camera angle, but I think it's a good time to check in with where we are on the build. I got those couplers because, as I talked about previously, you can't thread rods in both directions, at least not with the preset inserts that I put into the aluminum blocks. Now, I did manage to get some correctly fitted swivel pivots to put in the middle that would thread rods in correctly. However, they were still a little big. I do not retract my suck at Bezos comment, but that's okay. You know, me being not a master machinist, there were some alignment issues getting those rods to meet in the middle correctly. So that little bit of play is actually working in our favor to get them to come together. And the solution that I came to was the very strong, strongest commercially available JB Weld. Yes, I know, bad blacksmith, but I think for these applications it'll have plenty of strength across these 3 joints. and I'm overall, happy with it. This is a Mark 1. I'm sure we'll do a Mark 2, which brings me to my next point, is I don't read good, or at least when it would be prudent to do so. So I've mixed the epoxy. I've applied it. And now I come to the realization that the set time is 4 to 6 hours. So slight problem. Okay, it's fine. Everything's fine. I'm a genius. You guys were way too worried. Everything's fine. Just like my buddy's bachelor party, I was able to fashion a splint out of some random bullshit to limp home with. It's solid, it's good. We're gonna let that cure up and come back in a little bit. And with the main body complete, it's time to tinker. I'm using temporary aluminum mounts for the springs because I'm not sure what configuration will work best. This is the original idea I had, with the leg pulled slightly up so that when she puts weight on it, it could flex its way down. Now, she wasn't a fan. For one, it had way too much give, and she couldn't put her weight on it comfortably. And for two, the rubber strips I put on the bottom of the foot were not gripping the floor well at all. So, back to the drawing board. First things first, I reconfigured the springs, and I added these brass stop plates. This limited the range of motion and helped keep the weight on the leg, and allowed her to push down, which gave her a little support. And for the grippy issue, simply a baptism in the nectar of Phil Swift. Flex seal across the rubber foot gave plenty of grip. I actually never use infomercial stuff, but it worked out pretty good. And here's where the magic happens. Freya loves that vest. Every time she sees it, she knows she's going on a car ride. But she hasn't been able to wear it since the surgery. So once she put two and two together, that the leg let her wear her favorite accessory again, it was game on. You can see that little nub going. And you can see here, it actually allows her to pick her other foot up and rest on the leg, so it's plenty strong, and she's starting to trust it. A little more practice required. But look at her go. She's still getting used to it, but she can definitely put more weight on it and gets around pretty well. It does slip off to the side, but when she wants to stand on it, she can kind of push it back under herself. Now, I'd better take her on a car ride, stat, or she's going to get a little upset. But she ended up liking it so much that I took her to her first chemo appointment wearing it. The doctor said she was very handsome. But let me know what you guys think. How did you like the build? What could I do better? Because I definitely want to improve this and get it closer to my original design that I had in mind. So, if you want to support Freya's recovery, check out my wife's paintings, see if you like some. If you want to support the channel, subscribe, like, give me some comments. I want to know what your guys' thoughts on the design are. But anyways, thank you for coming with us on this journey. I can't wait to keep going. And thank you all again for tuning in.